Hello, everyone. We will begin our discussion in Chapter 7. Our topic will come from a collaboration where I plan to cover Section 7.1, which is properties of real numbers, and we will discuss those properties and review that accordingly. We will also cover Section 7.3, solving linear equations in the layout of ax plus b equals c, and we will work through some examples there, uh, discussing how to solve a linear equation in that model. Also, we will look at models on Section 7.4, solving linear equations in the layout ax plus b equals cx plus d. So we will look at several models that will assist you with being successful with solving linear equations in this layout. And our final topic is where we will work with formulas and just look at the layout of how to solve working with formulas and solving for variables given that formula. And that will also assist with just making sure we understand how to solve various linear equations. So let's begin with section 7.1. All right, so let's identify property of real numbers that justify given statements. So with these properties of addition and multiplication, let's go through the various properties and understand the characteristics of those properties. First property is commutative property. Commutative property, I like to give it a nickname flip-flop property, because if you look, a plus b equals b plus a, and that's what's happening in this property. The numbers simply flip. Likewise for multiplication, ab equals ba. So in this example, 3 plus 6, when it flip-flop, it will equal 6 plus 3. That's commutative property. 4 times 9, when it flip-flop, will become 9 times 4. That's commutative property. So just to identify the property, that is the characteristics of commutative property. The second property, associative property. A plus B plus C equals A plus B plus C. And notice here that we have the same thing on the left, same on the right. The only movement occurs is our parentheses. So in the addition model of 2 plus 5 plus 4 equals 2 plus 5 plus 4, you will notice the parentheses shift from the front to the back, which highlights the associative property. Likewise, for multiplication, A times B times C equals A times B times C. So here we have the same 6 times 2 times 7 equals 6 times 2 times 7. How can we identify this as associative? The parentheses shift. Here on the left side, they're at the back, versus on the right side, on the equal sign, they're at the front. That represents associative property. Next two are identity and inverse. The identity for addition means you get the same thing. Anything you add to 0, you get that number. 20 plus 0, we know that equals 20. In multiplication, anything we multiply by 1, we get that same thing. So a times 1, we get a. Negative 2 times 1, we get negative 2. And inverse is for addition, is where you simply get 0 to represent the inverse for addition. So whatever you get for a, for like 10, when you get the negative of that, that is 0, and that represents the inverse. On the multiplication side, we want it to be equivalent to 1. So a, when we do the reciprocal of that, that will equal to 1. Likewise, if I do the reciprocal of 3 times 1/3, notice here the 3's, they will cancel out. Next property, zero factor law property, is simply just as it states. Anything you multiply by 0, you get what? 0. And lastly, the discussion is distributive property of multiplication, which we kind of work through here in the midterm part. Distribute 3 times x plus 5 by multiplication. Distribute 3 to x, 3 times x. Final result, 3x. Distribute 3 to 5, 3 times 5. Final result, 15. That's a distributive property for multiplication. So that is the summary of section 7.1. Here, let's look at an example to make sure we understand the various properties. State the name of each property being illustrated. So here, if we notice, -7 plus 13 equals 13 plus -7. What do you notice? It flip-flopped. What is the flip-flop property called? That is correct. Community property of addition. Here, 8 plus 9 plus 1 equals 8 plus 9 plus 1. What do we notice? That the parentheses is in the back on the left side. They move to the front on the right side. What is that property called? Yes, the associative property of addition. So hopefully here, -25 times 1, hopefully we know that's the identity property for what? Multiplication, the multiplicative identity. And then what's happening with 3x plus y? Well, when I pass 3 to x, that's distributing 3 to x for 3x. Pass 3 to y, that's distributing for 3y. That's the distributive property. So hopefully that does help to understand how to identify the various properties. Okay, model A of section 7.3, let's look at how do we solve a linear equation in that particular layout of AX plus B equals C. So typically what will happen is that we will always solve for that variable. So in model A, the variable we see is simply X. And mostly it'll be X, Y, Z, A, and that nature. So the first thing I need to identify before I can solve for X with 3X is identify that this +3, I need to shift and do the opposite and make it a -3. So I will make it a -3 and align it with -18. I then have -18, -3. Of course, we're using calculators here, but that will combine to give me a -21. There, I then bring down my 3x, and 3x and a -21, divide both sides by 3. And what do I realize? That x, when I divide 3 to -21, becomes a -7. Final answer. So there, if I want to do a check, I will simply do 3 times -7 plus 3 and see if that comes out of -18. So here, by me doing 3 times -7 plus 3 equals -18, I will determine if that is correct. And what will I realize is that I get a -21 plus 3. And then I realize that yes, that is true, that I get a -18. So that checks out, -18. Here, B model, if I simply look here at B model, -26 equals 2y minus 14 minus 4y. Well, here, if I realize I have 2y and a -4y, and I need to combine like terms. So that's the first movement I need to do here, is combine like terms. So a +2, -4, that will become a -2y. What's left? -14. And then we know on the left side, we still have -26. What will occur next? I will identify this -14, but I need to deal with the inverse to combine it with a -26 by doing the opposite, so I will add 14. So whenever we combine like terms on opposite sides, we always do the opposite. So here, that's just the algebra rule. We will add 14 to both sides. Whenever I do the one side, I must do to the other, that's why that cancel out, leaving -2y. And there I show -26 plus 14. That will give me 12, and not just a +12, but a -12. So what will occur here? I will divide both sides by a -2. And there I'm able to see that y will equal a +6. Final answer there. Here, model C, 5.1x plus 7.4 minus 1.8x equals negative 9.1. We will also proceed to do the same process even if it is a decimal. So as we begin this process, let's go and realize that I have a negative 1.8 and 5.1x. So here what I will do is I will show 5.1, and that's a negative 1.8. And that will become 3.3x plus 7.4 equals a negative 9.1. So here I will take a positive 7.4, and again I'm solving for x, and I will do a negative 7.4 on both sides. So I have 3.3x left on this side. So now let's take a moment and show I have 9.1, that's a negative, and then I have here 7.4, and that's a negative. And that should give me a negative 16.5, okay? And last step is to simply divide that by 3.3. So I will take that and divide this by 3.3, and there's my result. X is equal to negative 5. Final answer. So here, even with the calculator, you're able to still move throughout and solve according to get X there. So that pretty much sums section 7.3. Okay, last two sections we will cover is section 7.4, 7.5, and here we're going to begin A and B on 7.4 in the layout of AX plus B equals CX plus D and solve A and B. And section 7.5 is where we're going to be looking at formulas and solving for those letters. So let's take off at 7.4, and here 5x plus 3 equals 2x minus 18. And of course, we're solving for x. Our standard note is that the x's are typically known to be on the left side, and our numbers are standard to be on the right side. So given that procedure, we will take 2x and do the inverse of that, since it's positive, and make it a negative 2x, and minus that with the 5x. I don't know, I have my drawing there, so my apologies. 5x minus 2x will leave me with 3x plus 3 equals, and if we recall, this is a negative 18, okay? Once again, I realize that I have a positive 3 that I need to shift. The numbers belong on the right side, so I will minus 3 on both sides. Here, 3x equals negative 18, negative 3. So there, that becomes a negative 21. Divide that by 3. And what do I observe? That x equals a negative 7. Final answer. So with that process, we're able to combine like terms on the opposite side by doing the opposite, and then we're able to do the inverse accordingly. All right, B model. B model, 4x plus 1 minus x equals 2x minus 13 plus 5. Now, in this model, we're doing a different approach because we have like terms on the same side. So when like terms are on the same side, you do what you see here. So with 4x minus x, that's exactly what I would do. 4x minus 1x will leave me with 3x. So now I show 3x plus 1 equal, on the right side, what will I combine? Just what I see, negative 13 plus 5. That result will become a negative 8. So there I have 2x minus 8. So now the process will be, I would take the 2x and it's doing across the opposite side. So that's where it belongs. So I will make this a negative 2x to move it to the opposite side. There I'm left with x, 1x, which is x, plus 1. And there I show a negative 8. So what will I do with this plus 1 is that I will make it a minus 1. And there I'm able to see that x is equal to negative 9. Final answer. So that's the process when we have that layout ax plus b equals cx plus d. Okay? And when we have to combine like terms. Now, last section 7.5, this can be a little advanced, a little challenging, but we still can do the process. Because notice what I'm trying to solve for is here is solve for the letter P, okay? That's what's highlighted. So I need to say, what's stopping me from getting P by itself? Well, I have K here on top. So what will that mean is that K is in the numerator. So to get rid of it, I need to do the opposite. So let's put it in the denominator. So what I'm doing now is multiplying by 1 over K. That's all we simply do is that process. So whatever I do to one side, guess what? I do it to the other side. 1 over K times here, V. And then I'm able to cancel out my what? K's. I'm left with my P. And there I see that P will equal, once I put V over 1 to make that fraction balance, 1 times V will become V, K times 1 will become K. So therefore, I'm able to see that P equals V over K. Final answer. Here at B model, solve for, once again, what we're paying attention to, Y. I need to figure out how can I get Y alone, okay? First thing I see with 2x plus 4y equals 10 is let's shift that 2x by making it a negative 2x. So once that occurs, I have 4y equals negative 2x plus 10. Okay? So what will occur now, I'm at a better place. I just have to get y alone. 4 and y represents multiplication. So guess what? I will divide each term by 4. So whatever I do to one, I must do to the others. And that's going to cancel out the 4s to give me y. And what will y equal? Well, I can reduce 2 fourths to 1 over 2 because I can divide 2 into 2 and get 1. That's a negative 1. Divide 2 into 4 and get 2. So that's a negative 1/2 x. And then I can also reduce by 2 with 10. 5 times 2, divide that out and get 5. And 2 times 2 and get 2. And there we have it. Y equals negative 1/2 x plus 5 over 2. Final answer. So I suggest you practice, rewind, practice the problems again, review the steps again, and I think you will be successful with HALT, with completing the work and doing well on the quiz. Please inbox me if needed. Take care. Goodbye.